Robert Goddard is generally accepted as the father of modern rocketry. Although rockets had existed for centuries, it was Goddard's advent of liquid fuel propulsion that would one day fly men to the moon. On March 16, 1926, Goddard made his historic launch. At first glance, the rocket's appearance is deceptive. Goddard believed the rocket would be more effective and more stable if its load was pulled rather than pushed. This belief led to the construction of two separate entities, the rocket support and the rocket itself. The rocket is comprised of several different elements, including the oxygen gas cylinder, not shown, the gasoline tank, alcohol burner, liquid oxygen or LOX tank, the gasoline line, LOX line, nozzle, combustion chamber, and igniter. To set off the rocket, the igniter and the alcohol burner were lit. Then pressurized oxygen gas was released into the fuel tanks. This pressure forced the two fuels into the combustion chamber where they ignited. After the rocket left the support frame, it relied on oxygen gas from LOX, heated by the alcohol burner, for continued fuel tank pressure.
Here is the assembly line. Glass wool insulation prevents the evaporation of fuel from the center section. With insulation in place, a tank for alcohol is lowered into the center shell. To the rear of the alcohol tank is a tank which will hold liquid oxygen. The supply line, which will carry alcohol to the rocket motor, runs through the center of the oxygen tank. The alcohol supply connection is completed and the oxygen tank is moved into position. With the fuel tank secure, the center section skins are fitted. A metal fairing joins the halves of the shell. As a further precaution against evaporation of fuel, the ends of the shell are packed with glass wool and metal bulkheads are installed to complete the assembly of the center section. This section is the basic component of the missile. Other sections will be attached to it as they are completed. Meanwhile, the propulsion unit is being assembled. Its principal part is the welded, pressed steel combustion chamber. Pre-formed fuel lines are fitted to the combustion chamber. Liquid oxygen and alcohol are drawn from the fuel tanks and forced into the combustion chamber by a centrifugal pump. The turbine of the fuel pump is driven by steam, generated by the violent reaction of hydrogen peroxide and sodium permanganate. When the propulsion unit has been fully assembled and inspected, it is placed on an assembly jig and fitted to the center section of the missile. Specially constructed frames which roll on tracks aid in the assembly. Preparations are made for final pre-launching tests. A trailing radio antenna is arranged in a pull-out box to ensure that it will not be damaged during the takeoff. Last operation in the preparation of the rocket for firing is the loading of fuel. First, 4 tons of grain alcohol are pumped into the upper tank. In the 60-second burning period, 9 tons of fuel will be consumed. When alcohol fueling has been completed, approximately 5 tons of liquid oxygen are pumped into the lower tank. An overflow pipe allows air and gaseous oxygen to escape during the filling operation. 380 pounds of hydrogen peroxide and 30 pounds of sodium permanganate are placed in the steam turbine pumping unit, which will operate the missile's fuel pump. The men who will launch the rocket report to the chief proof officer. Final weather and wind velocity checks are made. Over a radius of 17 miles, field stations are alerted. Radar devices are warmed up and adjusted. Special cameras are ready. Hundreds of electrical control cables extend from the missile to a stoutly constructed blockhouse. Roofed with 27 feet of reinforced concrete, the blockhouse will protect the launching crew in the event of a misfire or explosion. Time is growing short. Control is assumed by the launching crew. Inside the blockhouse, a carefully planned schedule is followed. The chief proof officer is in constant contact with all field stations via telephone. The commandant of the proving ground makes a final check on the preparations for launching. Three minutes before launching, marked by a flare from a Very pistol. Two minutes before launching. One minute. Twenty seconds. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Rocket away. Now, radar tracking devices swing into operation. 4 seconds have elapsed. The rocket is now 1 mile up. Its sound is still deafening to the ear. Telescopic cameras follow the course of the missile. 60 seconds have elapsed. The rocket is now 20 miles up and traveling at 3,000 miles an hour. Automatic recorders plot signals from the rocket. 3 minutes and 45 seconds have elapsed. The missile has reached its highest point, 100 miles above the Earth, more than 10 times higher than any airplane has ever flown. Radar technicians forward information to the blockhouse. A forecast is made of the location.
Until 2 days ago, that sound had never been heard on this earth. Suddenly, it has become as much a part of 20th century life as the whir of your vacuum cleaner. It's a report from man's farthest frontier, the radio signal transmitted by the first man-made satellite as it passed over New York earlier today.